In this module, we're going to explore data that are best described by the relationships between entities. And this will be done using graphs or networks. And while this is exploratory, at the end of this, you will have an understanding of the differences, different types of graphs, for example, directed and undirected graphs. You'll have a good sense of which type of graph you should use for different types of data or knowledge that you would want to represent with these graphs. And we'll get some hands-on experience with working with graphs using the Python package NetworkX. While there's no quiz for the module before class, I would like you to go over the Khan Academy Introduction to Graph Theory and look through this Introduction to Graph Theory with Python. Notes on Graph Theory is a mathematical exploration of this for advanced high school students if you're interested in looking at that. But it's really more of these first two that I would like you to look at. So to give you an idea of what we're talking about with graphs, graphs are a data representation consisting of nodes and edges. Nodes are the entities, and edges are relationships between these entities. So here are a few examples of type of graph data that you might run across in biomedical informatics. So for text, so here's a graph representation of features that have been extracted from a sentence and the relationship for them. So for example, here we have the concept pneumonia, and here we have a concept old, and we're saying that the old has a relationship with pneumonia, that it's describing this as a previous experience of pneumonia. And we have examinations, we have negations, no, prior kind of historical concepts. So these nodes, the ovals, are concepts that were extracted from a sentence, and the edges are the relationships between those concepts and the sentences. And you can see that these edges are arrows, and that this is a directed graph, that there is a relationship between reason for and examination that is different than the relationship between examination and reason for. Another common type of network or graph is a social network. And here the nodes are people and edges are the relationships, for example, friendship or co-authorship. And while these are showing arrows, most likely a social network would be considered a non-directed graph in that the friendship doesn't have a directionality to it. A third example are ontologies, or where we use relationships to model knowledge. So this is a low-resolution image of a cell ontology. And then we have a directional relationship because you have an ISO relationship. So if I think of more of like a disease, you would think of a melanoma is a kind of cancer. And so cancer is a more general concept, a parent of a child concept, or more specific concept, melanoma. There are a variety of graph tools available in Python. We're going to use NetworkX, which is a pure Python package. If you're interested in more speed, GraphTool or Python iGraph might be alternatives to consider.